Good morning, viewers. Today, our topic is earth backfilling and compaction. What is earth backfilling and what is compaction? We will know more details in the coming slides. The contents: material used for backfilling, compaction in layers, field density of soil, equipment used to determine field dry density, soil test, safe bearing capacity of soil, safety measures, types of compactors, standard penetration test, pile foundation photos, checklist, and photos which gives good compaction ideas. So these are very important. We will discuss one by one. Yes, about myself. I am N. Srinivasa, a professional civil engineer. My credentials are: I have 30 plus years of experience in the field of construction, backing with engineering degree from recognized university and completed PMC. I am a member of the Institute of Engineers and a registered engineer in BBMP. I worked with many reputed builders, contractors and MNCs and ran my own construction company. I have expertise in various kinds of constructions including residential, commercial and industrial buildings. I am well versed with ISO standards for quality, environmental and OSHAs. I have done construction audits, observations, checkings and improvements for many reputed companies, manufacturing units, contractors, builders, developers and for all types of construction materials. I do training and development for all engineers in the field as well as institutions. What is my mission? I committed to bring appropriate values and quality in construction by serving at least 1 lakh people across the country. Please subscribe to my channel for more videos like this called My Home, My Design. Now, what is earth backfilling and compaction? In civil engineering construction, we should understand properly the meaning of backfilling, which actually is the process of replacing the soil that is removed during building construction in order to strengthen and to give stability to the foundation structure. Hence, it is necessary that we should always go for approved earthback material for the backfilling. After soil testing, the soil with the liquid limit greater than 65% and plasticity index greater than 35% should not be used. See here, point to be noted. In civil engineering construction, backfilling, if you understand the term backfilling, what exactly is backfilling? What are the materials used for backfilling? See, unprofessional people will go for the construction. They not bother about all these things, what the technical people says and what the technical scripture as per IS standards says. They are not know all those things. That is the reason they are just use whatever the material, local material available there, they are using for the backfilling material, which is not at all good. Later stage it develops cracks and all. Then what is the right way? The backfilling material, always we should go for the approved backfilling earth material as per IS. Okay, that which should give the indication that soil with liquid limit greater than 65% and plasticity index greater than 35% should not be used. It should be less than within these limits. How do we know that? We need to go for the soil exploration test for such type of results. Okay, so this is the understanding of this paragraph. Now, clay soil is not allowed for backfilling. The reason being that the characteristic of clay is it shrinks when dry and expands when wet, results in the development of cracks at a later stage. Yes, what is this clay soil? In Kannada, we call this clay soil as JD Mannu. Yes, this JD Mannu, the characteristics is, so as it clearly explains, when it shrinks, dry, and when it expands, it wet. So that means as a result of it, if we use this type of soil, clay soil in the backfilling material as a backfilling material with at a later stage which develops cracks, and as a result of this whole soil is a shrinkage, the floorings also go down and cracks will develop, and a later stage it is poses a problem, serious problem for the structure also. So that is the reason the clay soil should not be used. Construction debris and soil with the organic material like grass, roots, shrubs and vegetation are not to be used for backfilling. You might have seen in the many places so much backfilling is happening. The filled up soil they are brought from some other place or maybe locally available material, which consists of a lot of plastic bottles, plastic materials, cover, dust covers, and all these things are not segregated and they are used for the backfilling material. Later stage, which creates a voids, and as a result of that, shrinkage is going to happen. That is the reason construction debris and organic materials are not suitable for backfilling. So backfilling material shall conform to one of the following types. We will go through that. What is that following type? The IS says backfilling material as the following norms. We will explain in the next slide.
See here, refer the table. Granular backfill, table 4.1. So what is that granular backfill? The, the sieve size 37.5 mm. So important. That means nearly 40 mm. The boulders, whatever the boulders are there, whatever the pebbles are there, which should pass through the granular sizes 100%, that means 37.5% easily it should pass through that 100%, then that is ideal. The sieve, if you go for the sieve analysis. Similarly, 25 mm sieve size, which is 85% to 100%, and 4.75 mm, which is again smaller, only the sand particles will go into that. 25% to 80% is allowed, and 425 micron 15 to 40% is allowed. 75 micron 8 to 18% it is allowed. So that means here what we understand here, the maximum size of the granular is 37.5 mm. So we can say 40 mm. The 40 mm size pebbles are allowed for the backfilling material. The rest of the things is, the remaining things are 25 mm, 4.75 mm and 425 micron and 75 micron. These are the various grades of well graded soil. This is the type of the soil we need to go for the backfilling. And similarly, gravel backfill, the 4.2 table explains the same thing. 37.5 mm sieve size, which is 100%, 25 mm 85 to 100, 4.75 25 to 80, and 425 micron, which gives mechanically compacted, we should give 15 to 40% passing material. And in case of 425 micron, so 5 to 10 water jetted soil percentages soil can be used for the backfilling. So these are the IS prescribed material ideal for the backfilling purpose. And then the process of compaction is to be done in layers of 150 mm depth. Based on the nature of the soil, the compaction equipment will be selected. See, that means what we understood now, the ideal backfilling material has to be selected. After the material is obtained, which gives 40 mm maximum size granular, and downgrade, as the previous slides we have explained, the percentage of passing 85 to 90% and 75%, 60%, 40% like that. So after obtaining the very good soil, ideal backfilling soil, then we need to go for compaction. The compaction, in the sense, the layer by layer it has to be done. The backfilling material, first it has to be filled in 150 mm maximum. That means 15 centimeters, 6 inches only, the layers. Then it has to be compacted. First layer has to be compacted, and then again refilling. Then second layer 150 mm compaction to be done, and again third layer. Like this, in layer by layer the compaction has to be done. This is the method we are adopting in civil engineering. Next, type of compaction equipment. What are the different types of compact equipments are there depending upon the type of the soil? One is, we can call it as cohesive soil, well graded granular soil, and uniformly graded soil. So type of compaction: pneumatic tired and smooth wheeled roll, which is suitable for cohesive soil, suitable for well graded, and uniformly graded soil, which is not suitable. Vibratory roller, which is unsuitable for cohesive, suitable for well graded, and suitable for uniformly graded. Similarly, vibratory compactor. Three types of compactors are there: pneumatic tired, vibratory roller, and vibratory compactor. So vibratory compactor, again unsuitable for cohesive, suitable for well graded and suitable for uniformly graded soil. So these are the types of compaction equipment and types of soil. Different types of compaction equipment is used for different kinds of soil. Now, field density of soil. Earth backfilling to be done with the proper consolidation, compacted at optimum moisture content, optimum in the sense maximum moisture content to a maximum of 95% proctor density or field dry density FDD for all footings up to top level, inside and outside plinth, and below granular GSP level, sub-base level. So these are the field density of the soil has to be identified with the proper consolidation, and it has to be filled in all footing tops, footing sides, and next below PCC. So sand replacement method or core cutter method is to be used for ascertain in situ field density of soil. This is the method we are finding out. So what is the field density of the soil in the field by means of sand replacement method. Consolidation, we used here the consolidation method. What is the difference between consolidation and compaction? See, consolidation is a process in which reduction in volume take place by squeezed out of water under constant static load. When load is applied to a soil, that causes the soil particle to pack together more tightly. See here, so I am explaining here in detail the load. When the load is applied over the soil with the constant static pressure, the soil is squeezed and it causes the soil particles to pack together tightly. That means which is tightly packed and no more water is left into it, which has already reached the saturation limit. This process is called consolidation. Next, here FDD field dry density readings for all column footings location inside and outside the buildings. Here you can see the field dry density 99.9%, 96.5% in the center line diagram. So this is the chart can be prepared by engineers, and the location and each and everything here they can mark it, and what is the location which gives maximum test after 3-4 samples taken. Everything has to be recorded in a scientific and engineering standard. So here the test has to be conducted by sand replacement method, the core cutting test. The soil is drawing out from the ground and it has to be sent to the laboratory, and their field dry density to be determined. When an area is to be backfilled, the soil is placed in layers called lifts, as I said, 150 mm. The ability of the first layer is to be properly compacted will depend on the condition of the natural material being covered. The layers should be 150 to maximum 200 mm in depth. See, this is very important. Sometimes if a weak strata of soil is found in excavated trenches, footings, and any other foundation areas, this has to be removed completely and replaced by strong compacted earth depending upon the type of structure, loads coming over foundation, etc. This is what I am stressing here. The weak strata, sometimes this whatever the available material digging for the earthwork, sometimes you might have seen a loosed soil or filled up soil which occur during excavation. Those type of soil already filled up soil with loose compaction will not be used for is not best suited for the structures for the backfilling. It has to be removed separately, completely it has to be removed, and which gives the field dry density, which gives maximum proctor density 95%. Those type of soil is absolutely required for the filling purpose, backfilling purpose. Those soil which gives like this type of color, granular, which has completely removed and the new material has done here, filled here. Advice. Actually, before starting excavation work, it is very much important that the strength and stability of the soil at various depth of foundation with respect to the natural ground level NGL of soil is to be determined by conducting soil exploration with the reputed agency. You might ask a question, so how can we know that whether this soil is best suited for the backfilling or not, and what is the weak soil which is not suitable for the backfilling purpose? Yes, of course. Before that, in order to determine what soil has to be used for the backfilling, better go for the soil exploration test. That means soil test in practical terms. Call the agency, reputed agency. They will conduct the test. 3-4 samples they will take out from the site, and with the help of those samples they will conduct the test field dry density test they will conduct in the laboratory, which gives 95% moisture content and proctor density, which gives a very good strength and stability result for the soil. Those test, if it is gives more than 95% proctor density, are advisable for the backfilling purpose. Obtain the test results from the field laboratory. Suppose if you not follow those terms, so what is going to happen during excavation in all types of soil, loose soil, as I told earlier, and all weather conditions, flood seasons, normally Bangalore is June, July, August, heavy rains is going to happen. Those times what is going to happen? There might be a chances of earth sliding, sudden earth collapse, percolation of water in foundation trenches, seepage of water from sides or bottom. All these factors not only affect the work but results in the safety of men working at the location. This is very, very important. Work can be done if it is close, that can be picked up in a later stage. But what about the life of the people, those who are working under such type of conditions, humanity? So which is very, very important. We need to give importance to the life of the people working there. It is the responsibility of project manager and safety manager to anticipate and foresee the problems, to take necessary safety measures from starting to completion, including updated documents. See here, manual excavation work in confined areas for existing building, including dewatering, is a challenging task. Of course, see here, lot of pipes are coming here. So if you just touch that while during the excavation process, there is a chances of blasting all these pipes, and there may be chances of some more water coming into this excavated trenches. In order to avoid all those things, care has to be taken depending upon the site conditions. Either you need to go for the temporary wall structure there to arrest the seepage of water, and then with the help of the pumps you take out water accumulated in the foundation trenches and do the compaction properly, and again PCC has to be done, and then put steel reinforcement footings, and then footing concrete has to be done, like that, till such a time the temporary whatever the wall you have built to sustain for the taking for the already seepage areas, so not allowed those overflow water into the freshly laid concrete and all. So like that, some measures has to be taken and it has to be arrested. Otherwise, if you still the condition is worst, then you can go for the better, you can go for RCC retaining wall where water accumulation chances are more. Next, the volume of backfilling for the designated area to be estimated. Plan accordingly before the actual work starts, and always keep an extra cushion of 25% to 30% quantity to accommodate loose earth volume to compare earth volume. So suppose we require 100% material for the backfilling, we need to order another 30% extra, because the loose material after compaction it gives a 30%, 130% gives 100% only after settled down. So that is the criteria. On that basis we need to calculate how much backfilling material to be ordered for the construction. See some of the photographs, you can see the different types of rollers, I mean different type of compactors are being used here. Use plate vibrators for completion of the earth inside for larger footings where the footing sizes are more than 8 feet, 9 feet. There the plate vibrator can easily go, and in the layers by layers 150 mm. With the help of the plate vibrators, the earth can be compacted. Suppose where these plate vibrators is in the confined areas, now it is not possible to take the plate vibrators into 5 feet, less than 5 feet width of the foundations. There the monkey jumper, which is nothing but a spring type compactor. If you can just switch on with the electrical switch, so which gives it's a keep on jumping with the vibrators, soil can be compacted very easily. So this is the type of the confined areas monkey jumper is advisable. And here, so some of the photographs you can see, this is the compaction test. And the core testing is taking out for the testing material from the soil, and earth backfilling for staircase in confined areas. So layer by layer, the compaction process is carried out. So this type of finishing you can expect in all project sites. See, the layer by layer compaction process inside basement using 1-ton vibro roller. After giving the sufficient level, then you go for the dry density test, which gives 95% or sometimes more than 95%, 98% dry density, the results which gives, that means which is almost equal to the natural soil. This test can be determined that yes, compaction test gives better results, then you can, it is ready for receiving PCC. See, similarly, 3-ton roller also gives, see here, the compacted, the difference between the compacted soil and uncompacted soil, here you can make out clearly after the 3-ton rollers in layer by layer compaction has done. You can find out yourself. Systematic way for backfilling of earth in layers with markings is a good practice. I'll explain here. You can see this, the depth of the beam is 600 mm. So that means 2 feet. In each layer, so 150 mm markings has been given. 3 markings, that means 150, 150, 150. So that means 450, and below plinth bed, another 150 is there. So that means in each layer, if you can adopt this principle, 150 mm thick cushion of soil filling, then compaction, then again second layer 150 mm filling, and then again compaction. Like that, filling, compaction can be done systematically. And then taking the second layer, you can take the test. So whether it has achieved 95% proctor density or not. If it is not achieved, then again you go for the compaction and then take the fresh reading to till such which gives 95%, more than 95% proctor density. Such time the compaction has to be done. So here the retaining wall is already happened. Here the sump tank walls, some of the columns casted below foundation level, and here again the systematic level of compaction is carried out. This is the site where all the activities, which is not depending upon one activity, which is not ideal, the simultaneous process of activities is going on here. So that is the importance of carried out some professionals in the civil engineering. Here also some of the photographs, you can see the earthwork excavation for amenities block, which is here. Already the main block is constructed here, but the amenities is a small block here coming up over in the first photograph. In spite of that small area also, we need to follow these standard procedures. The second photograph indicates after leveling of backfilling, keeping boulders separate is a good practice. So you remember very well that the maximum size of boulder or pebble is allowed for the backfilling is 40 mm only. Precisely 37.5 mm, roughly it is 40 mm, which is more than 40 mm. 40 mm is only this much size. So which is more than 40 mm size, the boulders. See here in the photographs, you can see that the boulders are maybe 8 inches, 10 inches, 1 feet boulders, all keeping separately. So they are not mixed for the backfilling and all. This is the scientific and engineering method what we are following here. So this photographs clearly indicates all these boulders more than 4 inches, more than 6 inches, and everything has to be discarded and not to be used for the backfilling. So now it is clear. See again, layer by layer compaction under process. This is the systematic way the compaction has to be done. The clearly these photographs indicate. Here also, this is very important. Sometimes the backfilling is depending upon the type of the structure. All backfilling is need not be the same. Some special techniques, some special requirements are there for the backfilling. See here, special type of coir rope mat being used for earth compaction in layers, total 9 layers surrounding bio lake area. See here, in the Titan project near Electronic City, behind DMart complex, we have done the bio lake has to be constructed. The depth of the bio lake is 1.5 meters. The whole thing has excavated, which is already waterlogged area. The whole thing has excavated, and here some special type of coir rope mat is used for in the layer by layer. In the next photograph, you can see the number of rollers are also available there. So the specification says the coir mat has to be spread evenly over that 150 mm, the backfilling material, which gives 95, more than 95% of the proctor density material has to be filled there, 150 mm, compacted properly with the help of the rollers. And then again, the second layer, coir rope has to be spread over again the compacted material. Like these 9 layers, imagine 1.5 meters, that means 5 feet depth. So it has filled, done in these 9 layers. So this is the systematic way, this is the scientific method which gives very strong compaction for the biolake area. See here, so many bundles of rollers, coil rope mat being used for the earth compaction. See, already I have told this is the in the systematic way, one after the other, one after the other, in a systematic way. The layers, the coil rope has been arranged in. This is the probably the 8th layer, whatever you are seeing here. Like that, the over here again the backfilling material has to be filled here, 150 mm thick, rollers has to be done 150 mm. Over that again the same type coil rope is coming over here. This is the special type the specification demands like this. Again, see here the columns are all casted here, but before going for the roof, before going for the roof casting, the PCC has to be done. The PCC in the sense plain cement concrete. For that plain cement concrete, we required a hard compacted surface which has to be filled in layers and compacted well before to receive that PCC. The site is systematically getting ready here. Compactor by using 2-ton vibro roller is a method. Here also we can see the flagging concrete which is giving the, otherwise it is called a plinth protection concrete, which is coming outside the building area. There also compaction is absolutely required. Here you can see here in 6 inches depth solid block has been putting over completely, and with the help of that the demarcation has been done. In between gap has filled with the material, backfilling material, compacted very well with the plate vibrators. Then the PCC, it is ready for receiving the flagging concrete. See here in the foundation pits also you can see the how beautifully the compaction has been done. See, core cutting is done on 16/7/2016 at 5:24 p.m. and the proctor density achieved 98.32% test results. Here you can see clearly, you can see the white samples W1, W2, W3 has been taken here. The volume is also recorded here. The dry density, bulk density, dry density, and MDD, maximum dry density. Here the proctor density. Ultimately the test results shows that we have achieved 98.32%. So this is the method we have to adopt in all project sites. See again the monkey jumper. In this photograph you can make out this is a confined area. Plate vibrators is not possible here. So that is the reason people are using here the monkey jumper or spring vibrator. Here also the compaction has done plate vibrator. Here you're using the column reinforcement is going on, but here in the ground the surface has been prepared to receive PCC. Again some of the photographs for the larger areas where vibro roller is in the process for the compaction. Here basement, here also you can see the markings 150 layers, 150 by 150, 150 in the column pedestal. It has been clearly marked, and see how the compaction beautifully is doing here. And the effect of soil type, if you can plot the compaction curve for arrangement of soil types, different types of cohesive soil, and compaction for the flat clay soil. So all these can be marked with the help of engineering drawings and sketches. So it can be dry density and water content versus water. If you plot the graph dry density versus water content, different types of soil, which gives the behavior pattern. Then we can identify what type of soil it is. Same thing, increasing comparative effort results in lower optimum water content and higher maximum drain. And finally, the checklist, whether the pre-existing execution checks have been done, yes or not. Checks during execution, these are all the checks has to be carried out. And standard penetration test, after all these things, some of the areas where the huge foundation is involved and the number of floors, let us say 20 floors, 15 to 20 floors or 25 floors, the mega structures is coming, there we need to go for the pile foundations. During that pile foundations, what the standard penetration test is absolutely required. The standard penetration test, SPT, is a commonly used in in-situ field test at project sites to define the relative density, safe bearing capacity, and shear strength of subsurface soils, and contains driving split spoon sampler into the ground using a consistent 63.5 kg hammer dropped from a height of 760 mm. This soil explosion test, either it can be used for pile foundations also and for the normal foundations also. This is the absolute test which gives a n value, standard penetration value, based on the number of blows. What is the strength that is determined, the SBC of the soil, safe bearing capacity of the soil is determined. With the help of that result, we can go for what type of floor, what type of foundation is required. Either it is a shallow foundation, deep foundation, or pile foundations. It can be determined with the help of this. And pile drilling, casting, and pile foundation. See here, after the pile drilling has been done, this is the drilling already done, and the casting is going on here with the help of the concreting, the funnel type, the pile foundation. The 600 mm or maybe 900 mm diameter piles has been used here. Some of the piles is already casted here. Some exploration is going on here. Testing is also going on here. In this photograph, you can see the types of casting, drilling, pile foundation, and everything can be seen in one photograph itself. After the casting has been done, pile foundations and everything done, whether the casting pile is able to take the required 20 floors load, the coming over, whether it is going to take it or not, the test has to be conducted. It is called group action of piles. The systematic arrangements of ISMB girders, placing over gunny bags, the sand gunny bags, over that number of bags has to be piled like this. Then the load is applied over it and recorded for probably for 24 hours or 48 hours. Each 30 minutes the readings has to be taken, whether how much load it is coming over the pile, and the pile is the deflection, how much deflection is allowed, what is the standard permissible limits. Everything can determine with the help of this test, which is called pile load test. See, improper compaction of earth results in shrinkage of beam bottom. So this is what I am always been advising in this presentation, that 150 mm layer by layer compaction has to be done. If it is not done, so this is the problem we are facing. Even the compaction of earth shrinkage after concreting, that means the shrinkage is happened, the plank, whatever the support has been given, it has already due to the shrinkage it is gone down. So that means as a result of that, the concrete is also going underway like this. That means improper structure. Here also, old concept of consolidation to be avoided and go for layer by layer compaction. Sometimes I have seen in the old sites also. So with the crowbar, people are doing with crowbar and completely 200 mm, 300 mm, or maybe 1 meter, more than 1 meter also, completely backfilled in one shot itself with the help of the tractors. And their crowbar, with the help of the crowbar, they make the holes, and continuous flow of water with the help of the pipes they are doing it. But this is not a genuine method. This is not a transparent method, which results later stage problems. Sometimes voids will be there in one place, and some places over water consolidation taking place after saturation point also, which is dangerous, which gives cracks and seepage and shrinkage. All these things happen if you followed this type of unscientific method. Again, you can see systematic way of how the compaction has to be done layer by layer. See here, compaction is done. The next second layer of soil is ready after evenly spreading. Again, the plate vibrator has to be run like this. Here also you can see layer by layer compaction is going on. See here, the improper compaction results in cavities. See, such type of cavities will be coming if you're not properly consolidated and properly compacted. Some of the photographs, good compaction methods, monkey jumper again, plate vibrators and vibro rollers, all types of compactors in one photograph. GSB, granular subbase laying over well compacted level earth surface in progress. Even for the roads also, compaction is absolutely necessary. Before laying for this granular subbase, earth surface has to be ready with well compacted to receive GSB, and over GSB also this type of compaction is absolutely required. Here you can see GSB laying over fully compacted earth surface, either for ramp, this is a ramp, and road. See, road, before doing all these things here, the drains has maintained very line and level and everything. It will act as a retaining wall to retain the earth for the road here. And then compacted surface, well compacted surface, the GSB has been laid, and again the roller is coming here. The roller will do the work here. Compaction has to be done in layers. Like this, the uniform surface can be built. So this is the presentation of compaction, how the compaction has to be done effectively. So before going for the normal construction practice, please subscribe, like, comment, share this video with all your friends, groups, family, and well-wishers. Pranams.